that frequency needs a cavity filter. That filter cannot be built in software to the same efficiency. So if you need a cavity filter, if you need to pass some spectrum and reject others, that can never be hardware software. So the question is, what can be virtualized? And that is why now the O-RAN project has been forced, but in the right way, which is the third disruption. So I already said there's a control plane, user plane disruption happening, which is one being driven by 3GPP. There is an NFV HTN disruption, which is being driven by ETSI for many operators around the world. Not everybody. AT&T doesn't buy that. AT&T's got their own app. And the third disruption is on the base station. So 5G is not about bigger, better, and faster anymore. 5G is about a different architecture. Is that architecture the need of the hour? Absolutely, it is. But just to close this topic, a very famous guy from North America who makes $1 million a year in these days, many of us know him, Tariq Amin, is now building the world's first cloud-native architecture in Japan. Rakuten is the 4th operator in Japan. Anybody wants to go to Japan, I can hook you up with Tariq Amin's right-hand man if you're interested. You still have to survive the interview. Tariq Amin's a very hands-on guy. This is a big marketing story at Mobile World Congress. What they're doing here is with O-RAN, you can virtualize the layers, as we said in the previous. So what are we doing in the previous slide? We're saying that, remember, one operator, one vendor used to own everything. If you had an Ericsson base station, then usually what we call it is the baseband, which is the digital unit, and the radio unit is where the separation happened. And it used to be over something called the front haul, which is usually CPRI, which is again proprietary. But it still was one vendor. O-RAN is saying, no, we're gonna break it at multiple points. One is the physical layer, which is the front haul. The second one is between the RRC and the higher radio resource control layer. So we are gonna start breaking things up, and we're gonna open those interfaces, and we're gonna force you to be interoperable with other vendors. So what's been the biggest advantage? Well, one vendor, which would never want its radio to work with a digital unit with another vendor, is now being asked to build a compatible, build it on the eCPRI, as they call it, an open interface for the front haul, and they have to be compatible. So that is the change which is happening, which has got many implications. Because it allows now smaller players to dive in, who can start doing their own vRANs. There are already 3 players in this. So Rakuten is about one of those small vendors who does a vRAN solution, which is known as Altio Star, working with a Nokia radio, as an example. That is the disruption that is happening. Are they going to be able to pull it off? Well, question mark. Maybe this is the first time it's happening. It's a tough one. It's a tough one. The good news for Rakuten is that they have a relationship with KDDI in Japan to start their launch as a mobile virtual network operator. So they've already reduced their risk of failure by saying, okay, we're already MVNOing with KDDI, so what? Now we will slowly introduce capacity and slowly roll out in a way. Why did KDDI want to work with Rakuten and kill themselves? Well, no, Rakuten is like the Amazon of Japan. So with this partnership, KDDI was able to give Rakuten their network. In return, they got Rakuten's extensive infrastructure at point of sales infrastructure in Japan. So it was a win-win for the two to allow them to happen. But then that allowed Tariq Amin to, I think, build this story. So this is the first in the world. This is what 5G is also about. But again, you can push back. If you're an analyst for Wells Fargo or JP Morgan and I'm on the call, you're going to say, Ali, how do I make money? You gave me a long speech. Where's the money? Show me the money. So the money here is, if I cannot create a revenue upside, what's the other way to create money? If you cannot improve the top line, what do? You improve the bottom line. So when you are virtualizing, the thinking is you're going to eventually reduce OpEx and CapEx. So the money is not necessarily in increasing revenue initially, but it's in the cost savings. In that sense, this is a slightly, can we call this a technology disruption? I can't say that because to me a disruption is when a new way of making money is. This is not disruptive enough because the target market is still to take away market share from, say, an Ericsson or a Nokia and replace that with another vendor. So it's still what I would say a very, very competitive and challenging situation. It's no different from 5G saying I want to take away market share from cable. Those aren't disruptive new business cases. A new business case is when Amazon says I'm going to change the way you shop. And 20 years later, we have not changed the way we shop. That is what disruption is. Or self-driving cars comes in and change the way your car ownership happens. That is what a true disruption is. So I'm not going to claim, I'm in this slide going to tell you what that true disruption is. I just want to say one last point is that the biggest problem for 4G has always been to get the cost per gigabyte to be competitive with fixed. Fixed is still like 4G still is $1 to $2 a gigabyte cost to the consumer, maybe not to the operator, but to the consumer. And the reason I say that is if you buy a $40 all-you-can-eat plan, if you consume, say, 22 gigabytes is the limit, 20 gigabytes, which is not the average consumption, you're still paying $2 a gigabyte to the operator. For fixed, if you are a fixed customer, you're paying, say, $50, so even say $100, you're still consuming 200 gigabytes on average from fixed because all of your Netflix is on the fixed network. So that's still 50 cents a gigabyte. In the worst case, it's even lower sometimes because consumption is going to 400 gigabytes a month on fixed. So can all these disruptions, the separation of the control versus the data, the separation of hardware and software, virtualization, and the disruption on the RAN, can they all lower the gigabyte per gigabyte cost for an operator? Is a question mark. But it is definitely going to happen as it's needed. So I'm going to now shift gears to a different problem. And the reason I'm motivated to do that is because Verizon and Cisco are saying they are going to work with 5G and SD-WAN. So now we've seen what is 5G. 5G is not a new business case yet. It's definitely a new architecture and it's pretty disruptive. But what is it that SD-WAN is? Any questions so far from anybody, please?
Yeah, I have multiple questions, but I can do it later.
You can let's do one of those questions right now, and then we'll continue, and I'll wrap up my speech.
First of my question regarding your spectrum on
5G. 5G spectrum.
Yeah, and what I understood from one of your slides is that penetration will be much lower because of the
millimeter wave. So the question is that if 5G has much lower penetration due to millimeter wave,
how are you going to control your capex? Because then you have to have a multiple.
Then how will you control capex? Well, we have the people who are actually deploying 5G in the room, but I'm not going to ask them that because they may have to give proprietary information. So what Verizon has already published on that is that they have identified areas where they're going to roll it out. And for that, they have created a slide showing, actually in their storytelling, that if you go to one of their analysts' presentations, they actually say to the question, how will Verizon control their 5G capex? So first of all, they've hired my fearless leader from Ericsson, who knows how to control costs. And it's not the best of environments right now, but people are leaving. 10,000 people have left Verizon, so that has been an OpEx reduction. So that's been really, so remember.
I'm not talking about OpEx, I'm talking about CapEx.
Well, if you reduce OpEx, you have money for CapEx. So that is the first thing.
Yeah, but still, for 4G, you still have these number of base stations, but the penetration much higher. It goes much more.
So the question is on the bridge to folks that how many more base stations will you need for 5G?
Exactly.
And the answer is that Verizon has estimated that for their 5G rollout, they will need maximum 15 to 20% more small cells. They're not going to change. That's been their estimation. But they have promised to the market that their capex is not going to go beyond a certain threshold. Whatever they forecast is going to be it. And up in 2018, after the tax environment that improved in spending, still Verizon kept their capex to what they had promised. They are one of the most organized shops in the world, I would say. So they have made that statement that it's a 15-20% increase of capex spend or site density, but they will still do it in a way. And how are they going to do it? By promoting virtualization, by promoting ORAN, by promoting these things which will, and what Verizon has done something much more important. They have brought in a third vendor, Samsung, just to fix the capex issue. Why do you bring a third vendor in? To increase the price pressure on vendor A1 and 2. Okay, so those are the techniques Verizon is using to control capex. But you are absolutely right. If you don't do it right, you cannot get to that type of performance to kill cable. My question is, why are you trying to kill cable? Why are you going into a market where the dog eats the dog? It's not the right. In strategy, you're taught blue ocean and red ocean strategy. Red ocean is blood. Everybody is killing. It's called the zero-sum world. Your loss is my gain. I haven't increased the size of the market. I've just stolen from you. That is the traditional red ocean.
Still, there is 330 million people living in the US.
So there are 330 million people. The opportunity definitely is on fixed, definitely, not on mobility, because mobility is maxed out. The question now is, where is the fixed a business case? Yes, it can be. So let me now move to SD-WAN. Now SD-WAN, you have to take a step back. Cisco has a different story because Cisco does not depend upon just service provider. That's just say 10-20% of their revenue. So if they make 49 billion a year, say 9 to 10 billion is from service providers. What does Cisco offer AT&T, Verizon? They offer them the core network. They offer a lot of the routers that go into building their site, etc. But when it comes to Cisco and some other players, they have a big enterprise footprint. And this on the slide on the left shows you what the Cisco traditional architecture used to be. There used to be in an enterprise, why do you need core aggregation and access routers? For Cisco, an access router is a router that goes in the edge, which is maybe an enterprise office. Usually, why did they need this architecture? Well, this works beautifully because enterprises used to have a major data center, which was their private data center where most of the information was. On the right is what's happened now, changed. The data center is no longer the private cloud. There is a bunch of stuff in the public cloud. So the traditional connectivity paradigm, which was to connect the enterprise network, the branches, to the private cloud, is changed to a combination of public and private. Totally different problem, but there are two things here. Enterprises are spending thousands and thousands of dollars on this connectivity. So SD-WAN comes in a very nice way to solve this problem, but let me keep motivating the problem. So today I'm just going to give you the problem statement to get you thinking about a different problem, because probably in the world of radio you never get exposed on a different problem. And it's a much easier level of difficulty if there is money to be saved than there is a real business case. So what is the business case? In the top slide, the traditional connectivity model, the branch is connected to the data center using 2 MPLS circuits. Why do you need 2 MPLS circuits, please? So why you need 2 MPLS circuits here? If you look at this top, and folks on the bridge, because, sorry, let me take it back. You need 2 because every branch wants a redundancy model. You know, we're talking about banking, financial transactions. You don't want the network to go down. So you have two for redundancy, and then through that corporate data center, you're going to the SaaS, the applications. This used to work in the good old days, but as more and more applications go to SaaS, this becomes inefficient for two reasons. One, you really want a way to connect directly to the internet from the branch, number one. And why do you want to have two MPLS connections to begin with? Why can't you have one MPLS and one internet connection? Well, before SD-WAN, you needed that redundancy. This is what SD-WAN does. It again breaks the control logic from the data logic. And it takes it to the control plane. And it says, okay, I'm going to manage all the network connectivity for you. The immediate output of this is tremendous cost savings right there. Why? One MPLS circuit. Guess what does one MPLS circuit cost in the United States today? Any guesses?
Business could be like $100.
Internet is $100. MPLS is $1,000 for 10 meg. So a branch has paying for one MPLS connection $1,000, for two or $2,000 average. Could be 800, could be 2,000, but average is 1,000. So we're saying that for that MPLS for 10 megabits, why is it so high? Because MPLS creates a dedicated connection. It's very fast, very good SLA quality, very low downtime, very low jitter, etc., etc. All the good things, but they come at a cost, and it takes a long time, maybe 3 to 6 months to get a new MPLS circuit up. So SD-WAN comes in and disrupts this traditional connectivity model for enterprises by reducing the cost. This is a business case coming from Cisco world, and they just did this analysis. The point I'm trying to make in that for small sites, for medium sites, for large sites, they calculated the legacy TCO per month, and they said for the legacy TCO, I'm going to overall reduce your costs by about overall about 25% for the large sites, which are the major driver. Why? Because you don't need that much MPLS connectivity anymore. Okay, I'm going to take away all that unnecessary. And how am I going to then manage it? Well, I'm taking the control plane in another place. I'm making you MPLS independent. Here in MPLS, well, you are working with a Verizon or AT&T for your connectivity. So it can be spun in two ways. One is the enterprise takes over the control. Verizon can spin it in another way. If you work with me, SD-WAN, I can also manage your Comcast circuits for you. So they're both, so it's a win-win for both enterprise and for SD-WAN. The point here is, just 30 minutes ago, I was talking about connectivity and whether you're gonna pay $50 or $60 for 100 meg. And we said that is a zero-sum game, it's not the right thing. Now we're saying all of a sudden, if you can give me a better connectivity, 100 meg for a certain quality, to all my branches, I'll pay for it, and I'm already paying $1,000. I'll pay $100. And so all of a sudden, Verizon and AT&T have a story, if they want. No, now it's not the fight to the consumer who is probably hiding behind that apartment complex. No, it's a branch. I know where the branch is. I can open up a map and see if my link budget will work to that branch. And I know where this customer has 500 branches or 5,000 branches. I'll make sure all branches have 5G connectivity, and make sure. So all of a sudden, SD-WAN becomes very, very interesting for a company like Verizon. Because Verizon is growing the enterprise business. Of course, it's also very, very important for Comcast and AT&T. Remember, business services is a big plus, because then you can add more services to it. And this is an example of the type of things an SD-WAN can do. It can, we call it a fabric because these connectivity diagrams are like tightly woven cloths, with all these fabric strings, all these connections, that's why they call it FWAN. So you can use SD-WANs to connect your branch, your campus, your data center to the public cloud in all sort of ways without the complexity of traditional networking. And traditional networking is very, very complicated. You know, BGP, and remember, when you start studying those, you start seeing what the complexity is and what the simplification is. So SD-WAN is a massive opportunity that is going to grow at a 30 to 50% CAGR year over year. One of the solutions is Cisco has, but there are about 23 players on the market. Today's discussion isn't about who is the better option. Of course, Cisco has a definite advantage because it controls the enterprise networking. But usually there are three, again remember, like 5G, which is coming today, this already has three planes, a data plane, a control plane, and you always, when you have a control and data, you always need a management and orchestration plane. Management is where you manage your VNFs, virtual network functions. Orchestration is where you knit them together to offer a service. And then you can offer this over MPLS, internet. If you can do it over 4G, you can easily do it over 5G. And why wouldn't you do it? 5G beats 4G in terms of performance. So how do we bring it all together now? And that is the end of my talk. And the opportunity. So there is a need for new skill sets. That's my punchline. 5G isn't just about bigger, better, and faster anymore. There are some more use cases out there which are low-hanging fruit. If done in a very strategic way, they can create value for players. Okay? As enterprise connectivity is a challenge, enterprises are still connected with DSLs. They should not be, but they're still putting DSL as one of the methods. So this is where Verizon, for example, has made key investments on their architecture, you know, on their access, on their Ethernet, FTTP, FTTC, and then how they have created a virtualized facility. They have unified their transport. They have created a multi-service edge. They have a converged core. So they've already transforming their network. They can already take an SD-WAN virtual function and put it onto their data center. But the point here is they are now ready to offer 5G and mobile SD-WAN, and that is the offering they are developing. That is the offering, that is the opportunity. What is the opportunity for you? What does it mean? Well, I've got you thinking about a different one. Just about 40 minutes ago, we were discussing is 5G got a business case or not? And remember, this is how business cases happen. You have to sometimes take your eyes out of the ball, the puck that you're watching so closely, feverishly, and saying, meaning I was just talking to my colleague from AT&T and yeah, help me with the business case is the question. Unfortunately, that is true because everybody's struggling. But all of a sudden, now we start seeing it may start making, I'm not saying it is a slam dunk, I'm not saying it's done, but I'm saying SD-WAN is creating cost savings, and the heart of the cost saving is to provide cheaper alternative to MPLS. That's it, that's the heart of the cost savings. Well, now all of a sudden, if you can automate it, make things simpler, easier, integrate them. So this is where then the opportunity becomes interesting. Cisco has three products basically that are transformative because Cisco is moving their product line to the cloud. Cisco, in that sense, is getting very good reviews from the stock market because they have changed their business model from a hardware-centric to a software-centric. So remember, if the market's going into hardware-software separation, control data plane separation, then why should you be selling hardware and make money from hardware? Hardware is now considered a commodity. Aha, the radio vendors cannot do that easily because radio physical layer requires hardware. So that's the challenge for a radio. But for an IP player, a network player, a cloud player, absolutely hardware is a commodity. And they've got two product lines. One is SD Access, which is transforming access. What does access mean in the IP world? Access means the branch, the campus. Just like the campus has hundreds of, tons of routers. I can't say all the time hundreds, but tons and tons of routers. They are going into SD Access, meaning there's a control data plane separation and a software-defined controller with a fabric Similarly, as I've said, SD-WAN. So they've got this, no other vendor on the marketplace has both. Okay, or maybe, well, let me take that back. Some of the smaller IP players like Juniper may have both. I haven't checked their product line. But again, Juniper is a tenth or maybe 20% of Cisco's revenue. So there are two product lines, SD Access, SD-WAN. One is to disrupt the access world, which is the branch, or the enterprise office, and the other is to disrupt the wide area network with new ways of connectivity at a lower cost. And this is where they are saying their vision is. They're already laying out the vision in a very nice way. This is the heart of their story. This is the heart of it, which is allowing them to say they are probably ready to fight Amazon now. Because they're saying we're going to go from best effort to manual to semi-automated to automated to total self-driving. So you can think about what are the skill sets of the future now. As they are moving to self-driving, they are making everything API-based. So just like Amazon, everything already is API-based, but Amazon, remember, doesn't have a network presence. It's a cloud infrastructure. You still need somebody to connect to that. That means you need network connectivity, be it a service provider or a vendor. And so this vision is compelling in the sense that it's showing you from best effort to self-driving, which would be the ultimate skill set. Now you get this concept. Now you can go back and look at 5G with a new eye and a new angle. That is what SD-WAN and 5G means. That is the end of my talk. I'm open for a few questions for the next 10 minutes. So anybody on the bridge first? Hey folks on the bridge, do you have any questions? Let me see if I muted you. Okay, you are unmuted now. No, I'm not recording this session. I'm sorry. No, yes, this session has been recorded. You're sorry. Any questions from the bridge? Okay, I'll be putting you on mute and I'm going to answer a question from the audience. Any questions from the audience?
I have a question. So about the revenue stream. So in the SD-WAN and 5G is not coming from the public. It's coming from the enterprise.
The revenues as well. SD-WAN's use case is enterprise, and not just enterprise. It's also IoT. It's also beyond the enterprise. It's all future networks. That's the revenue stream. And yes, the money is in enterprise. Yes, and that is what actually the analysts, when they analyze, one of the reasons, what I've heard from analysts, they give a very hard time in their evaluation to Big Blue, which is, downtown. And the reason they do that is because they're saying you're going into new areas like media. But come on, you're being killed on your bread and butter connectivity for enterprise. The best place would have been to defend that territory. That's the feedback that I've heard analysts say. So yes, enterprise got a lot of challenges, connectivity challenges. For them, spending $100 to save $1,000 is no big deal. So that is, if you've got somebody willing to pay you $100 for a 100 megabit connection with all the good things, you go for it. It's a less cutthroat market because enterprise, you do not have to go sell to a consumer. You have to have sales teams selling to businesses, which is a totally different ballgame than selling directly to consumer, which requires a massive publicity effort and then the whole market share game. It's a tough one. It's a very brutal one. So yes, enterprise is the opportunity with SD-WAN. Can we? So the question which I'm leaving the audience to think about is, can we marry 5G and SD-WAN? That is our vision as an HTN, and we would love to collaborate. That's why we're having these talks. We'd love to collaborate with smart people like that, and there are many disruptive product development opportunities, software development opportunities here. but all of them require thinking outside the box. You cannot think linearly and traditionally. Yes, sir.
So, just want to know what is the opportunity for. I've been working in the RF industry for the last 20 years.
Come in here. So your question is, I'm
what
an
is the opportunity?
RF engineer. What should I do? Is that the question?
Yeah, you can take it.
So I've been working in the RF engineering industry. Well, first of all, as an RF engineering skill sets should be going towards more and more automation over the next 3 years. If not, there is something fundamentally wrong. And every decision maker knows that. RF engineer, whenever you have a large supply of engineers who are working at a low rate, first of all, Uncle Sam is working hard to make sure that model goes away. And they've been very brutal with companies bringing in cheap labor to the US market. Okay, so that is the first dynamic. The second is, well, you have time. It's not going to go away overnight. You have to be reskilling yourselves. Now, you can either reskill yourselves in 5G, but going from 4G to 5G is not a massive skill set change from a radio angle. It is a massive skill set change from a network angle.
One question, 5G standalone versus evolution.
So the question is 5G standalone versus 4G. Which one gives a better 5 ROI? That's already been tested. The answer to that is very well known. It was done 10 years ago when WiMAX came standalone. It was killed. You never roll out a new layer of technology with nothing to fall back on. Okay? Unless your target footprint is not consumer, it is, say, a business, an enterprise. Say your 5G use case is no longer a macro cellular network nationwide. It is to have a 5G deployment in this factory floor so you can automate ultra low latency applications. Then you should go 5G standalone, definitely, because why waste your time with a 4G core? But the only time a 4G standalone network has been done with scale that I've seen, which was impressive, has been done once, in my knowledge. It is Jio in India. That Ambani guy, he did something amazing. He built a new network it took him 2 years to build a network, and he was bleeding like hell. That's why we didn't work with Ericsson, except for consulting. Our colleagues went to India on behalf of Ericsson. I was asked, hey, do you want to go to India to consult with Ambani? So they wanted us for consulting, but they didn't want us for the hardware. And then the Ambanis took Samsung in and they built a 4G network from scratch. They did not have to do any worrying about any legacy, pure IP network, and so it can be done. But is that possible in 5G? Well, you need to again find a situation like India again to make it happen. Yes, dish and cable MSOs can have 5G, you are right. It's absolutely correct, but nobody knows what Charlie's game plan is with his spectrum. The reason why he's got that beautiful AWS spectrum, people are hypothesizing it's 5G, but come back to the laws of economics. If Verizon is struggling to make 5G a killer success, what makes you think a dish can make it a killing success? It's a question mark. So even their AWS rollout of narrowband IoT, according to many people, don't quote me because I'm going to try to go to Dish to win some business, is about license protection.
One more question.
Yes.
So what are you offering right now in this discussion?
We are offering an SD-WAN training path if you are motivated and dedicated to the transformation.
So what will be the roadmap for the RF engineers to learn from scratch to going to that level? So every RF engineers right now, they want to see how they can improve their skill set.
So the question is, what will be the road? If you are a radio engineer, how can you become an SD-WAN guy? So what we're saying is these opportunities don't come every day. These opportunities come when there's something disruptive happening. So SD-WAN changes the paradigm of networking in a way that you do not have to go and build a BGP routing table anymore. So to build a BGP routing table, you need to do a CCIE, which is about 2-3 years of work, and you can still not beat somebody who's doing networking for 20 years. But what we can do if you're getting into SD-WAN is there are 2 skill sets that are needed, and that's what I am teaching and I'm training. First, you need a crash course on network fundamentals. A CCNA usually, for an average guy, takes 2 months. For a super smart person, you can get it in 2 days, the essentials. You can't pass the CCNA, but you can get the gist of the material in 2 days. So we've designed a course that gets you the material in 2 days. And then we give you training and practice, and then we build a roadmap on top to get you SD-WAN trained and then deploy it. So we do not argue. We argue you should not leave your job and say, I'm going to become an SD-WAN expert. What we argue is you have to do it slowly. So what is step 1? Step 1, keep your job. Step 2, shut off your Netflix subscription. You cannot watch Netflix in the nights or on the weekends. Number 3, start working with us on your weekends. And maybe in 6 months, if you work with us, we can change your profile. Yes, that's what the confidence with. Nobody else in North America is making that claim because nobody knows what radio guys are capable of doing. Yes, the way for you to work in this area will be to get into a little more skill set than just simply learning protocols. You will have to know the new paradigm, API programming, a little bit of Python. You will have to learn machine learning to differentiate on the marketplace. You will need these 3 skill sets because remember I said, total automation. How do you get to total automation? You need machine learning for total automation. Next question, please.
What will be the per hour rate in SD-WAN compared to the RF engineering?
So look, supply and demand economics. When the demand was less, when the demand was high, supply was less. Even an LTE engineer commanded $125 an hour, a very good engineer. So today, SD-WAN engineers are commanding $150 an hour plus for the consulting business. The best of the best are making a killing, $500. But this is not going to last for long. At the same time, the number of enterprises that are going to migrate to SD-WAN are not going to be over in a day. It's going to take 3 to 5 years. There are problems to be overtaken. So the skill set I'm recommending is not just SD-WAN, it's a combination of SD-WAN, it's an understanding of cloud technologies and machine learning skills. And then you can, if you get your hands dirty, then you can either come work with us or you can start changing your profile, and yes, you will get jobs. It's just started. Yes, there is not one solution in the marketplace. There are 3 or 4, according to Gartner, there are 4 big players right now in it. But yes, any question? Did I answer your question, please?
Thank you.
I'm not saying you're going to fall asleep and I'm going to tell you everything in your sleep in your ear and you're going to become an SD-WAN expert tomorrow. That's not going to happen. You know that. You're smart. Most of you are smart enough to know that. Any question on the bridge? Yes. So you mentioned Viptela Cisco. Yes, Viptela Cisco paid me $1 million to say Viptela. Okay, come on, man. So why not Versa? Why not Nuage? Well, you mentioned VeloCloud. There are 4 massive players. So you are right. Viptela Cisco is one of the solutions. Nuage, well, Nuage isn't among the